This is step assignment 5. It's to do, well, the main step question is to do with a tetrahedron. I'll go through all of the questions on the assignment now. So we've got a right angled triangle and we just want to prove the Pythagorean identity here. Okay, so if we just have a triangle, we'll call this A, this B, this C. I'll just say that C equals 1. And then sine theta we know is just opposite over adjacent. So sine theta is just going to be A over C, which will just become A because C is 1. Similarly with cosine theta you get B over C, C is 1, so you get cosine theta equals B. So that equals B, that equals sine. Sorry, that equals cosine theta, that equals sine theta. And because of Pythagoras' theorem, sine squared theta plus cosine squared theta equals C squared, but C is just 1, so it's just equals 1. The points A, B, and C, basically we've got a triangle and it looks something like this. Now your triangle might look a little bit different depending on whether you choose A to be larger than this X here or less than it, but it doesn't actually matter. We've got the lengths B here, C here, and that's all that we're given. What I've done is, because we want to show this, what I did was I thought, well, we've just looked at Pythagoras on the other part of the question, and the way that step works is that they use the first part of the question to kind of hint at what they want you to do in the next part. So I thought to myself, I'll try and make a right angle triangle, so I'll connect these two here. This is the point X, this is the point A, so this is X minus A. And similarly, this is Y because we're just going from 0 to Y. Okay, now using Pythagoras' theorem, we have X minus A squared plus Y squared equals C squared. Okay, but we also have that X squared plus Y squared equals B squared. Okay, we just want it in terms of B squared, C squared, and X squareds, or X's, and A's, apparently. Okay, so I just rearranged and I got rid of what we don't want. What we don't want is Y. So just rearrange for Y here and then just put it there. And then just rearrange it a tiny bit to make it look like that. And that's it. That's fine. That's what they want. Angle ACB equals C. So that equals C. Express X in terms of B and C. Okay. If you've not seen this before, this is just it's called like Cauchy's theorem. Al-Cauchy's theorem, maybe, like the proper name for it. You might just know it as the cosine rule though. Okay, what I've done here is I've taken this and I've just expanded it, and then I'm going to distribute the -1 to get this. I've also said that cosine C is just going to equal X over B, so it's just adjacent, so X over the hypotenuse, which is just B. Okay, that tells us that X equals B. Cosine C, you'll get this. I rearrange for C, and then you can just, plug in this for X. You'll get A squared plus B squared minus 2 AB cosine C, which is what that is there. For some reason, I paused and I realized that I actually just didn't plug this in for some reason. I think I just forgot. But I've explained it here, so you know how to do it. Now we're on to the preparation. We've got a triangle, AB. Just label these sides. You've got AB is 10, BC is 9, and CA is 17. Find the value of cosine C. Okay, so this is the value C. They've just shown us cosine rule. Okay, so we'll just use it. Remember, it's C squared equals A squared plus B squared minus 2AB cosine C, I think. Okay, so you get that. Just rearrange for cosine C. Just multiply out very carefully. You don't get a calculator for this, but if you just do this slowly, you should be fine. You'll get cosine C equals 15 over 17, and you can just leave that as that. It doesn't ask for the angle yet, so you just leave that. Find the value of sine C using question 1i, hence show that the area of the triangle is 36. Now, they've asked you to look for sine C. Now, if we're looking for the area of a triangle and we're looking at sine, the first thing that should come to your mind is half AB sine C. That's just the equation for the area of a triangle. Okay, A and B, that'll just be, what can we do? We can do 17 and 9. Okay, is that what I did? So that's 90 plus 63, so 153 over 2 sine C. Okay, now we've got cosine C, but we want sine C. If I square this, okay, Then I think to myself, well, we know that sine squared theta plus cosine squared theta equals 1 because we proved that in 1i. That's what it's referring to here. We can say that 1 minus sine squared theta equals cosine squared theta. But we know that cosine squared theta is 15 squared over 17 squared, so we'll plug that in. So sine squared theta equals this, once you do a tiny bit of rearranging. And then if you just square root both sides, so you get 8 over 17. You do get plus or minus 8 over 17, but if you think about it, the way that the sine graph works, so it goes up like this and down. Okay, and at 90 degrees, you've reached a peak. I think it's called a trough, actually. No, it's called a peak, I think. Okay, and then at 180 degrees, you go down to 0. Now, between 0 degrees and 180 degrees, sine is positive. Now, clearly, it's not going to be 180 degrees, because if that one angle there is 180 degrees, all the others must have to be 0, and then therefore that makes it a straight line. Or like, I can't remember what the name was, it's like a deformed triangle or something like that, I don't know. But this angle C clearly has to be less than 180 degrees and greater than 0 degrees. So therefore sine is positive within that range. So we just take positive 8 over 17 and then just plug that into there and you'll get an answer of 36. Okay, this is another preparation question. I thought that was the step question. We've just done this 2i up here. And so for 3i, we've got this 3D arrangement here, and we've got a rectangular base pyramid. Okay, we've got the points 0, 0, 0, and then 4, 0, 0. So we're going across 4, upwards 0, and then into the screen or outside or out of the screen 0. Okay, and then we're going 0 across, 6 up, and we're not going into the screen or out of the screen. So that's somewhere there. Okay, now a rectangular base pyramid, it looks something like this. Hopefully you know that. And so you think to yourself, find the coordinates of the 4th vertex. Okay, if we just say that we've got one point there to make this rectangle here, okay, then the vertex could just be over there, and so you'd have this rectangle here, be this one here, and then the vertex, which all of these vertices meet to, will be here. Okay, hopefully that makes sense. Now you could also have it on this other side here, so it's hard to show, but like not on this side, but on the other side, if you just reflect it in that plane there. Okay, yeah, then we can just say, well, we're given the volume of a pyramid. Are we even looking for the volume? Oh no, we're looking for the vertex at the base, sorry. But for some reason I decided to do this part first, I think. Oh no, I didn't, okay. We're saying that the volume is 1/3 area of the base times by height. Now, the base here, this is the point 0, 0, 0, and this is the point 4, 0, 0. So it's 4 across, okay, and it's 6 upwards. So 4 times 6 is 24. This is just a rectangle. So it's 1/3 24 times by the height h, and that equals 40. Okay, so you can just multiply by 3 to get 120 over 24. Okay, or just not do that. You can just do 24 over 3, which is much easier. And then 40 over 8 is just h equals 5. Okay, now if h equals 5, it means that from the base of this rectangle here to that vertex, you're going into the screen by 5. Okay, it's a little bit weird to think about, but it's directly over the center, I think it says somewhere. Yeah, given that the apex of the pyramid is directly above the center, write down its coordinates. But it would just be for the 4th. Oh, sorry, no, I'm looking at this. For the 4th vertex, it would just be you're going 4 across, and then you're going. Sorry, what? Okay, sorry. Yeah, I've done this part of the question before this one. The 4th vertex, 1, 2, 3, 4, is just this one here. So it's 4 across, 6 up, and then that's that. And then the apex is this one, which we just worked out, which would be what would it be? 2, 3, 5. The reason why it's 2, 3, 5 is because the apex is directly above the center. So this is the point 0, 0, 0, and then this is the point 0, 4, 0. And so if you average those points out, you're going to be 2, 0, 0 to get here in the middle. Okay, and now there's 6 up in total, right? But you want to go halfway because it's from the center. So half of 6 is 3. So you're going across 2, going up 3, and then you're going into the page 5 because the height was 5. So the apex is just 2, 3, 5. Okay, hopefully that makes sense. Simplifying the case where x is greater than or equal to 0, and then what is the answer if x is less than 0? I've seen questions similar to this before, and whenever I do a question that looks difficult like this, what I think to myself is, if I see any repetitions, I just make a substitution. So I just said let y equals 1 plus x squared, so then I can say that this is 1 over y, and this is the square root of square root of y squared. Okay, or just y to the half. Oh, sorry, not square root of y squared, just the square root of y, which is y to the half. Okay, and I made this y over y, and then I put them over the same bracket. Sorry, over the same denominator, like that. And if you've got an object that looks like this, you can just say it's y minus 1 to the half over y to the power of a half. And then the y to the half here cancels with this y to the half, so you just get y minus 1 to the half. Plug in 1 plus x squared back, you'll get x squared to the half, so you get plus or minus root x squared, so x is just, all this just equals x. Okay, if x is less than 0, then it would just be minus x, because if you have a negative number here and you're squaring it, you're still going to get a positive number and then square it, but you're going to take the negative solution, so it'd just be a minus number, I think. Now, for the step question, we've got part I. We've got these points here, O, A, B, C. Okay, and that's this. Now, A, B, and C are all positive. Okay, let's just focus on part I first. Okay, we want to find in terms of A, B, and C the volume of the tetrahedron. It gives us the formula for the volume is 1/3 area of the base times by a height, as we've just seen earlier. So if we just draw a just like a graph, right? And then okay, we've got 0, 0, 0. That's, you know, trivial. It's just there, obviously. And then we've got A, 0, 0. So we're going across A. Remember, A is positive, so we can say it's there. Okay, for the next, and we're not going upwards or into the page or out of the page at all. Now, for the next point here, we've got 0, 0 across, and then 0 into the page or back. But we're going B upwards, which is just somewhere there. Okay, now the third point here, other than this one here, obviously, is you're going 0 across, and then 0 up or down, but we're just going C back, so it'll be somewhere there. So if you connect this with this with that, and then connect that to that, that to that, and then that to that, you'll get what's called a tetrahedron, as it tells you here. Now, if you've not seen what it looks something like this. Okay, we're told that the area is, sorry, the volume is just 1/3 area times by the height. Okay, well, the base is just going to be half, and then we're going across A, up B, so it's half AB, because remember this is a triangle, times by the height, which is just going to be C here. So it's just 1/3 times by the area of the base here, so half AB, times by the height C, and that just gets you 1/6 ABC. So that's the first part. Now for the next part, we're told that first of all these are labeled A, B, and C. Okay, so I'll just label them here. Okay, they're saying let angle ACB, so ACB, so this angle here, let that equal theta. Okay, roughly you're gonna have a triangle that looks like this. Okay, we're ignoring the tetrahedron part. This is just this triangle here in red. Okay, and we want to show that cosine theta equals that. Now remember, the preparation that we just done had hinted at cosine rule. Okay, let me just label that angle there, theta. It hinted at cosine rule. Okay, now we can express this length here, BC, the length AC or CA, and then the length BA or AB, in terms of A, B, and C. Okay, and this here is in terms of A, B, and C. So we can relate cosine theta to that with cosine rule, or Al-Kashi's theorem, as I mentioned earlier. Now, BC, well, to get from B to C, you think to yourself, it's on that same like plane there. So if you just imagine this as X, and then this is Y, okay, you go in C across, and you go in B upwards. So this length here is just going to be the square root of B squared plus C squared. Okay, and that gets you the length BC. You should say magnitude of BC, to be honest. Doesn't matter. AC, okay, if you just imagine this flat triangle here. Okay, we're going A across, and we're going C upwards, or into the page. Okay, and then that means that the length CA, just using Pythagoras, is going to be the square root of A squared plus C squared. Okay, and similarly, AB, this one's probably the easiest one, sorry, is going to be square root of a squared plus b squared, and that gets you the length AB. Okay, let's use cosine rule. So if we just imagine this be A, we'll have, if you just, it's AB squared, it's A squared equals B squared plus C squared minus 2BC cosine theta is how I remember it. So that's just this length squared equals this squared plus this squared minus 2 lots of this times by AC and then cosine of this angle here. Okay, if you plug that in, that just looks something like this. Just plug in BC, CAB. You know, we've just written them here, so just plug it in. Be very careful. This cancels with this cancels with this. You've got 2c squared here, bring it to the other side, you get minus 2c squared. Cancel, divide by minus 2 on both sides to get c squared equals that. And this, you can just put it over the same square root, so you can just do all of this to the power of a half, or all of that under one square root. You'll get this, and if we're looking for cosine theta, just divide through on both sides, you get that. That's what it wants, that's fine, that's the answer. Okay, what am I doing now? Am I looking for the next part of the question? Okay, yeah, I think I'm looking at the next part of the question, my bad. But yeah, that's the next part now. Remember the we're looking for the area of triangle ABC now. Remember, the area of a triangle is just half AB sine C. Okay, so half, and then we can say this multiplied by this sine of this angle here, sine theta, that equals the area. Just remember what we're doing in the preparation. That's our area. Okay, we've got cosine theta, but we're looking for sine theta. So let's square this, okay, and then use the Pythagorean identity. So cosine squared theta, or I've changed it to a c here for some reason. But anyways, cosine squared c is going to be this. Don't actually go ahead and square everything, just leave it like that. So don't expand out the bottom part just yet. Okay, remember, cosine squared c is just 1 minus sine squared c. Just because sine squared theta plus cosine squared theta is identical to 1. Okay, so this is 1 minus sine squared c. Just rearrange for sine squared c, and then square root to get that. Okay, and then you can go ahead and expand. Just be really careful. You get a squared b squared, and then a squared c squared, and then plus c squared b squared, and then the c to the 4 cancels with this c to the 4. I don't know why I've not expanded that at the bottom. Okay, yeah, I've not done that just yet because you'll see. I think stuff will do some cancelling. As you can tell, I've actually made these slides quite a while ago and only decided to upload the video now because I've just been busy. Anyways, you can put this all under the same square root, okay? And then this here will cancel with this. So you're just left with the square root of this top part here. Okay, and that equals our area. And that's fine. That's just in terms of A, B, and C. So that's that next part done. We're told next that the perpendicular distance of the origin from the triangle ABC satisfies this. And we want to show that. So what D actually represents here is a point from 0, 0, 0 to the triangle there, but it makes 90 degrees with the triangle. Okay, hopefully that makes sense. Now, using that, you can use the formula for the volume of a tetrahedron, because now you've got a tetrahedron with these 4 points. Okay, where the height is just going to be this D here. Okay, and then the area of the base is just this triangle's area here, ABC. But remember, we know that triangle's area. Okay, it's this one here. And then a third of that times by D. Okay, that's fine. That's where I got this from. Okay, but remember, at the beginning, we said that, if I go all the way back, maybe. Let's see, where is it? That's way too far back. Where is it? It's somewhere here. I said that the volume of the tetrahedron OABC is 1/6 ABC. Okay, but now we've got a new equation for it, which is this one here. Okay, so the volume is just 1/6 ABC, as we'd already worked out. So that means this is equal to that. Okay, now the next part of the algebra is it's a bit difficult. It's not that it's difficult. It's just that making one small mistake can set you back quite a bit of work. So you just have to be really careful. Times by 6 on both sides. This becomes this will cancel with this third almost entirely, and then you'll have a 2 left over, and then the 2 multiplied by the half just makes a 1. So you just get this equals that. Okay, and then what I did was I squared both sides. If you can notice here, we want everything here squared. So you know, it's probably a good idea to make it look like what it wants. So square both sides, this becomes d squared, and then this square and square root cancels, and then you get a squared, b squared, c squared, like that. We're looking for d squared, okay, so maybe it's a good idea to divide through like that. And then we're looking for 1 over d squared, so let's just find the reciprocal, get that. And then we think to ourselves, okay, well, we've got these 3 terms here at the top, and they're dividing by one thing. That just means that we can split them up into this divided by that, plus this divided by that, plus this divided by that. As you can see here, we've actually not done anything. It's just that when we're combining fractions, it's just like we've gone backwards. And then the a squared and a squared cancel, b squared, b squared cancel. Similarly here, a squared c squared cancels with a squared c squared, then you've got c squared b squared cancels with b squared c squared, and you'll get that, which is what they wanted you to show. Okay, I've just rearranged it a bit to look a bit like that. Now for the 1 down question, we've got a drawer full of identical socks, red socks and blue socks. How many socks must I take from the drawer to ensure I have a matching pair? Okay, so to ensure you have one matching pair, the way that I think about it is, what's the worst case scenario? The worst case scenario is, let's just imagine, let's say we want two red socks, so a pair of red socks. I think to myself, well, it would be annoying if I took 1 red sock out and then I got a blue sock, so that cut off that chain of red socks, and then I could possibly get another red sock, and then that way I would have 2 reds, so that makes a pair. But say on the 3rd time that I picked it up, say I got a blue sock, it doesn't matter, because that remember, my second one was blue. So if my first one was red, my second one was blue, my third one can either be red or blue, because either way I'd still get a match in pair. But say that the second one was red and the first one was red, well, that would just be a pair in 2. But the minimum amount you'd have to take to ensure that you got a matching pair would be 3. Okay, so I think, do I write it out here? Okay, sorry, no, that was for the next part. Oops, did not mean to show that. Now, to have 2 matching pairs, well, let's just use the same idea. We'll write it down a bit more systematically. Let's say the first one I take is a red. Okay, remember, we're looking at the worst case scenario. We want to have 2 matching pairs, so let's say I take blue next. Okay, now whether I take blue or red, I'm going to have at least 1 matching pair, so let's just say red. It doesn't matter. Okay, if I pick blue now, then that means I'm going to have 2 matching pairs, and that means we'll have 2 matching pairs and 4. But that's actually not the best thing we can do yet, because what if we picked another red, right? This way we still have only 2 matching pairs, because blue is still unmatched, but we've only got 1 match of red. Okay, now the last one, X, whether that be red or whether it be blue, we'll have at least 2 matching pairs. If it was blue, we'd match this with that. If it was red, we'd match this with that, and then this with that. And then that's 2 matching pairs. Okay, so the minimum number for the worst case scenario would just be 2, 4, 5. So it's just 5 here. Okay, now how many socks must I take from the drawer to ensure I have n matching pairs? Okay, now the mark scheme is very particular about this. It says you can't just extrapolate and just say, just look for like a pattern and find an expression from that and just say, oh, well, that's my answer. They actually want an explanation as to why that is the answer. Okay, let's just say, what if we take, how do we get 3 matching pairs? Okay, I will actually use extrapolation first, and then I'll explain my answer right after. Okay, let's say we want 3 matching pairs. Okay, let's say we start with red, we go with blue next, then we get red again, then we get red again. So far it's the same setup as the next one, as the last one. And now it doesn't matter what the next one is, but let's just say it's blue, just because. Okay, so we've got 1 pair there, another pair there. Now if we get another red, then that means we're going to have another pair with red. So let's not go for a red, because we want the worst case scenario, remember. So we want a blue. Okay, and then we should probably just go for a red, right? It doesn't actually matter whether we go for a red or a blue. We'll still get another another pair. So let's just say red. Okay, and so that tells us that we need 2, 4, 6, 7 to have 3 matching pairs. So 1 pair we need 3, for 2 pairs we need 5, for 3 pairs we need 7. And so here you can kind of see that we need 2 times the number of pairs plus 1. Okay, 2 times 2 is 4, plus 1 is 5, 3 times 2 is 6, plus 1 is 7. And then to get 4 pairs, it's just going to be 4 times 2 is 8, plus 1, which is 9. And so if we want n pairs, this is just going to be 2n plus 1. Now the explanation as to why this is the answer, first of all, we'll consider 2 cases. Let's say we have an even number of red socks and an even number of blue socks, so we'll just say 6 and 6. Now, if I take 24 socks, so 2 times sorry, not 24. If I take 12 socks, of course, because 6 and 6 is 12. If I take 12 socks, I will have 12 matching pairs. Okay, so if I take all the socks from this, I'm going to have 3 pairs here, and then we're going to have another. Sorry, that should say 6, not 12. Obviously, I don't even know what I was thinking there, but that's obviously 6. Okay, so if I take all 12 socks, I'm going to have 3 pairs from this one. Okay, and another 3 pairs from this one, so that's 6 pairs in total. If I have an odd number of socks, so 7 red and 7 blue, so odd red, odd blue. Okay, if I take all of them, how many pairs can I actually get? Well, if this was 6 and 6, like I said, we could take 6 pairs up here from up here. If this was a 6, imagine that as a 6, right? So I could get 6 pairs, but I'd have 1 spare red and then 1 spare blue. Now I can't make a pair with that because they'd be mismatched. So with 14 possible socks, I'd only be able to actually use I'd only be able to make n minus 1 pairs. I've just gone back and amended this error here. Anyway, so what I was saying, if I take 7 red and 7 blue, so if I take 14, I'd only still have 6 pairs. So notice how here I have 6 pairs and here I have 6 pairs. Okay, so if I have an odd number of reds and an odd number of blues, or an even number of reds or an even number of blues, I will still have the same number of pairs. But it becomes a little bit different, say once I have maybe an odd number of reds and an even number of blues, or vice versa. So we'll need to think about it a little bit differently. Now in this case here, if we just think about it backwards, okay, now if we want, say, 6 pairs instead of n, we'd have to take 2 times by the number of pairs, so take 12. Okay, now if we think about it like that, and then for an even case, in this one here, if we want 6 pairs, we'd have to take 6 times by 2, which is 12, and then an extra 2, which is 14. Okay, now wait a minute, actually you could do this in 13, sorry. That should be 13, not 14. Just fully messing up in this question here, but it would be 13. Okay, because it wouldn't matter whether I pick the last one, because regardless, I'm not going to be able to make another pair, so that should say 13. And the way that I thought about it was, if we think about this case here, imagine you were listing out n pairs, right? Obviously you can't, but just imagine you were. You'd have one that matters, and then one that doesn't matter. Because irregardless, you'd still have another pair. So you have matters, doesn't matter. Okay, and you'll have matters, doesn't matter. Matters, doesn't matter. Okay, so if you have say n pairs that you want, right, and this is even, you'd have 2n that you'd have to take to get n matching pairs. But if it was, say, an odd number, right, you'd have 2n, and then you'd do the +1, because you're not sure if you'd have to account for that last one or not. But because we're assuming the worst case scenario, you would just account for it, because you don't know if this is actually going to be odd or even, if the total number of socks is going to be odd or even, right? I don't know if I've explained that very well. I hope you understand it. If you don't understand what I've just said, I will link the mark scheme. But um, I'll just say that one more time. So we have matters, matters, doesn't matter. Matters, matters, doesn't matter. Matters, matters, doesn't matter. Okay. Now, like I said, because we're assuming the worst case scenario, because that way we're ensuring we have how many matching pairs we want. You'd always do the +1. 2n, just assuming, okay, well, if this is even, then we'd have 2n. But we'd have to take an extra 1, which would be the one that matters. Okay, when I said matters, matters, doesn't matter, etc. Right? So the extra 1 would be the one that matters if this was an odd number. Right? Hopefully that makes sense. Just because, so even if it didn't matter, then you'd still check it because you're playing the safest strategy. So taking 2n+1 is the safest way to go, because irregardless of what you pick n to be, you'll always ensure that you have n matching pairs from taking out 2n+1 socks. Right. That's it. Thank you for watching.